In this presentation, we will use Excel to make a dot plot which will look for similarities in two DNA sequences. A dot plot is a concept from bioinformatics. We will take two nucleotide base strings, combinations of the letters A, C, T, and G, and we will look for sort of subsequences within the strings that match. To start, we will enter the two sequences into Excel in cells A1 and A2, just to copy and paste. Excel has a length function, len, that we can use to determine the length of those strings. So in B1 and B2, in B1 we have the formula equal len open parenthesis A1 close parenthesis. The length of the strings being used here was 60, so we will set up a 60 by 60 grid. So starting in D3, we start with the number 1, and then in E3, 2, and then copy those 2 and copy the pattern across. Excel will find the pattern and continue it and go up to 60. Similarly, in C4 and in C5, we enter 1, 2, and copy that pattern down and go to 60. And then we could highlight sort of all the cells by clicking the gray in the corner that's next to A and above 1, and then get to a double-headed arrow between two columns and double click, and that will sort of make all the columns thinner. We are going to look for sequence matches of various lengths. To start off with, we're going to start off with a length of 1, and so we're putting that in B4. Now we enter in E4 a function that looks for matches. We're going to break down this formula over the next few slides, but basically it's going to look in the string in B1 at various positions, but in a given cell in a particular position, and in another position in the second string, B2, and it's going to look for matches of a length given by B4, so right now lengths of 1, so matches of one letter. And if there's a match, it's going to enter a 1, and if there's not a match, it's going to enter 0. But we're going to break down this formula more. So we are starting to break down this formula. The main function is an if equals if, and remember in an if there is a condition, something we're going to test, a true-false question, and then followed by what you want to do if it's true and what you want to do if it's false. So we have these two mids, we'll talk about more, but we're asking if two mids are equal. If those two mids are equal, we're going to put a 1 out, and if they are not equal, we are going to put out a 0. So mid takes a string, the function mid takes a string, and then produces what we call a substring, some little portion of the string. And so the first argument in the mid function is the string we are taking. So in the first one, it's $B, $1, the first sequence of DNA, and the second mid, the string that we're taking is $B, $2, which is the second base sequence. And they have their dollar signs, so we can, in both the letter and in the number, so we can copy any which way, and the first mid is always referring to the first base sequence, and the second mid is always referring to the second base sequence. The second argument in mid is where this substring, where this little part of the string, where it begins. So again, $B, $1 is the first base sequence, and $B, $2 is the second base sequence. And then we are using mid to look at subsequences, and we're going to start those subsequences at different positions given by the second argument of the mid functions. So the first mid function has a second argument of $3. So that means when the formula is copied, the E can change and the 3 cannot. So we are copying it both across and down, and so the copying across will change the letters, E to F to G and so on, but the 3 will always stay a 3. Remember, when we established the grid, we put the numbers 1 through 60 in the third row, so we are always referring to these numbers. The second argument in the second mid is $D4. So this time it's the D, the letter that stays fixed, and the number that changes. So again, this formula gets copied over and down. And so when we copy it over, the letter does not change because of the $, but the numbers will change. And we've set up another sequence of numbers 1 through 60 in column D, so we are always referring to one of these numbers. So the positions vary. The third argument of a mid is the length of the subsequence or the substring. Both mids have a third argument of $B, $4, so they are asking for the length to be the same. This is the cell in which we entered the length of the match we're interested in, and again, when it gets copied, it changes neither letter nor number, so the length argument in the two mid functions will always be the same. They'll always be the same length, and they will always refer back to cell B4. So again, if over all is going to have a true-false question, and then what you want to do if it's true and what you want to do if it's false. The mid is asking these two substrings or little mini base sequences. We're asking if they match, if the two. So the mid is pulling out the two little subsequences, and then we are with the equal asking if they are a match. And then if they are a match, we will put out a 1. If they are not a match, we will put out a 0. Then that formula is copied all over the grid, both across and down, to fill the grid with this formula. So here we are just showing the grid filled in with that formula looking for matching subsequences. Next, we're highlighting the match outputs in the grid and doing some conditional formatting. So then the 1s will be a different color from the 0s, and this will make it a little bit easier to look for matches. Here's the result of the conditional formatting, where the 1s have turned red and the 0s are black. So we are looking for matches. We are looking for red colors. Right now our match length was a 1, so that's not much of a match. But we can, if we see diagonals, then that is going to correspond to a longer sequence. And as we change the match length, it's those long sequences that are going to sort of survive the longest. So here we've changed the length sequence in B4 from 1 to 2. So there are fewer reds around. And here's the change to 3. So again, with each increase in the match length, we're going to find fewer and fewer matches. So here's a question for you to investigate. Keep increasing the match length in B4 and answer the question, what is the longest match between the two sequences that you found? Next, we'll ask the question, what if sequence 1 got turned around? What if the match that we're interested in is not between sequence 1 and sequence 2, but the reverse of sequence 1 and the original sequence 2? What then? How do we handle that? So we want to use Excel to turn that one sequence 1, around and get its reverse. So we copy it over from the previous sheet and put it in cell B1. And then in A2, we're entering a 60, and in A3, we're entering a 59. We're going to highlight A2 and A3, and then copy down that pattern until we get down to 1. And then in cell B2, we're going to enter the formula equals mid $B $1, which is the big sequence, comma A2, which are these numbers 60, 59, 58, and then a 1. So we're always referring to the original, the string at the top, $B $1. The position of the substring A2 will change, become A2, become A3, become A4, so that that position is decreasing, and we are always taking a length of 1. So you see that there, that in cell B2 we have T, which was the last letter. In B3 we have A, which was the next to the last letter, and so on down. With cell C1 empty, we're going to enter in C2 the formula equals concatenate, open parenthesis, C1 comma B2 close parenthesis, and then copy that formula down. Concatenate means sort of stick one thing right after the other, stick B2 right after C1. Well, B2 has the last letter T and put it right after nothing, so that's where the T comes from. Then we go down to cell C3 and we're sticking an A after what we had before, which was T, and we just continue that process. So we are taking our reversed letters that are in the column B and we are reconstructing a long string from them. So at the bottom of C we will have our reversed string. So we are going to take that result that we just got at the bottom of column C on sheet 2, and we are going to copy it, and then we're going to go return to sheet 1, our original sheet, and we are going to use paste special values, and I'm entering it in cell B3. Remember that that formula was obtained using a formula, and Excel tends to prefer when it copies to copy formulas. But if we don't want the formula copied, but just the result, then the copy is the same. You don't do anything to the copy. But when you paste, you say that you want to paste the values, and that is paste special values. So now we have to make one modification to that formula that was comparing subsequences. Remember that it had two mids, and it was asking if those two mids were equal, and the first argument of the one mid was $B $1, and the other one was the first argument of the other mid was $B $2, and now we just have to change the sequence and from $B to $1 to $B $3. That is the reversed version of the first sequence. And then we play the same game again. We take our match length, which was in B4, and maybe start at 1 and work our way up and see what the long sequences were between the second sequence and the reversed first sequence.